Wait a second. This is not right. Let us rewind a bit. Alright, so from this video we can clearly see that the person fell over because he threw an object. Now the reason why he did this is because of Newton's laws. So that would mean... let me switch to a better color here. Newton's laws. And friction as well. We can explain this first by using the concept of inertia, but let's start off by drawing Alex. So, let's draw the first frame, which is this key frame right here. And that is when he first prepares to throw the ball. Alex. Now, from this diagram, we can write two main forces, because gravity is clearly negligible at this moment. So first we can write the force that he applies, which it is a common misconception to think that is the force that he applies on the ball, because at this moment it is not a part of a system yet. So we can instead write the force that Alex applies on the ground in the other direction, which would be equal to F A. Don't forget the vector. Now, we can also write friction because, well, it's grass, and that would be in the opposite direction, resisting the applied force. So that would be F. And at this moment, he is not moving because of this friction, and because this is friction, it is stopping the object from moving, which would result in an acceleration of 0. Now this is from the moment where he pushes off the ground. What about the moment where he falls forward? Well, we can draw that first, so that's what it kind of looks like. Now we have extra forces acting onto it. Firstly, we have gravity. Next we have our force forward. The force was going behind before, but now that he is moving forward, the force is in the other direction, and because the force is now going to the right, the friction will be going to the left. Now you might be wondering, well, if friction was equal to the applied force, why is he still moving forward? And that's because of this graph here. Once friction reaches a certain point, it will drop in magnitude and be constant all the way. So, because of this, instead of staying still, Alex is instead moving forward with some great acceleration. Now we can apply the concept of inertia, which means that an object will keep doing what it is currently doing if not opposed by any force. Although that's quite impossible in this video, because, well, as we can see, there are friction and gravity. It comes quite close. Theoretically, the applied force was so powerful compared to the friction that if overcome his kinetic frictional force, which would keep him moving forward until he fell because of gravity, which he eventually did. Now this also means that the net force, which is the sum of all forces added up, is not equal to 0. And when F net, the net force, does not equal to 0, that means that both of mass and acceleration have to be more or less than 0. Now, we can't have 0 mass and we can't have negative mass because, well, Alex is so obese, so it can't be mass. Then it must be acceleration propelling him forward, which means that he must have an acceleration moving so fast that he falls. Now, judging from this video, Alex likely anticipated that the ball's reaction force would push him back, which is not possible, because let's draw a diagram of him and the ball when they first contact each other. Now Alex is applying a force on the ball, which is Fa, and the ball would have a force back, which is the same force that he applies to the ball. Now, as we remember, the ball has no friction because it is in the air. However, Alex does have friction, and Alex does have acceleration. So Alex's F net and the ball's F net are equal. However, their masses are unequal. Therefore, their acceleration must not be equal because, well, mass and acceleration are inversely proportionate. So Alex, because of his obese weight, must have an acceleration that is less than the ball. Much less. Which wouldn't really push him back as he anticipated. Therefore, not doing anything to stop him from going forward, which explains how he fell in the way he did.